Top interview question answers on machine learning. Q1. What is the difference between supervised and unsupervised machine learning? Answer. Supervised learning requires training labeled data. For example, in order to do classification, a supervised learning task, you'll need to first label the data you'll use to train the model to classify data into your labeled groups. Unsupervised learning, in contrast, does not require labeling data explicitly. Q2. How is KNN different from k-means clustering? Answer. K-nearest neighbors is a supervised classification algorithm, while k-means clustering is an unsupervised clustering algorithm. While the mechanisms may seem similar at first, what this really means is that in order for k-nearest neighbors to work, you need labeled data you want to classify an unlabeled point into, thus the nearest neighbor part. K-means clustering requires only a set of unlabeled points and a threshold. The algorithm will take unlabeled points and gradually learn how to cluster them into groups by computing the mean of the distance between different points. The critical difference here is that KNN needs labeled points and is thus supervised learning, while k-means doesn't and is thus unsupervised learning. Q3. Explain how a ROC curve works. Answer. The ROC curve is a graphical representation of the contrast between true positive rates and the false positive rate at various thresholds. It's often used as a proxy for the trade-off between the sensitivity of the model, true positives, versus the fallout or the probability it will trigger a false alarm, false positives. Q4. Why is naive Bayes naive? Answer. Despite its practical applications, especially in text mining, naive Bayes is considered naive because it makes an assumption that is virtually impossible to see in real-life data. The conditional probability is calculated as the pure product of the individual probabilities of components. This implies the absolute independence of features, a condition probably never met in real life. As a Quora commenter put it whimsically, a naive Bayes classifier that figured out that you liked pickles and ice cream would probably naively recommend you a pickle ice cream. Q5. Explain the difference between L1 and L2 regularization. Answer. L2 regularization tends to spread error among all the terms, while L1 is more binary/sparse, with many variables either being assigned a 1 or 0 in weighting. L1 corresponds to setting a Laplacian prior on the terms, while L2 corresponds to a Gaussian prior. Q6. What's your favorite algorithm, and can you explain it to me in less than a minute? Answer. Interviewers ask such machine learning interview questions to test your understanding of how to communicate complex and technical nuances with poise and the ability to summarize quickly and efficiently. While answering such questions, make sure you have a choice and ensure you can explain different algorithms so simply and effectively that a 5-year-old could grasp the basics. Q7. What's the difference between type 1 and type 2 error? Answer. Don't think that this is a trick question. Many machine learning interview questions will be an attempt to lob basic questions at you just to make sure you're on top of your game and you've prepared all of your bases. Type 1 error is a false positive, while type 2 error is a false negative. Briefly stated, type 1 error means claiming something has happened when it hasn't, while type 2 error means that you claim nothing is happening when in fact something is. A clever way to think about this is to think of type 1 error as telling a man he is pregnant, while type 2 error means you tell a pregnant woman she isn't carrying a baby. Q8. What's a Fourier transform? Answer. A Fourier transform is a generic method to decompose generic functions into a superposition of symmetric functions. Or as this more intuitive tutorial puts it, given a smoothie, it's how we find the recipe. The Fourier transform finds the set of cycle speeds, amplitudes, and phases to match any time signal. A Fourier transform converts a signal from time to frequency domain. It's a very common way to extract features from audio signals or other time series such as sensor data. Q9. What is deep learning, and how does it contrast with other machine learning algorithms? Answer. Deep learning is a subset of machine learning that is concerned with neural networks, how to use backpropagation and certain principles from neuroscience to more accurately model large sets of unlabeled or semi-structured data. In that sense, deep learning represents an unsupervised learning algorithm that learns representations of data through the use of neural nets. Q10. What's the difference between a generative and discriminative model? Answer. A generative model will learn categories of data while a discriminative model will simply learn the distinction between different categories of data. Discriminative models will generally outperform generative models on classification tasks. Q11. What cross-validation technique would you use on a time series dataset? Answer. Instead of using standard k-folds cross-validation, you have to pay attention to the fact that a time series is not randomly distributed data, it is inherently ordered by chronological order. If a pattern emerges in later time periods, for example, your model may still pick up on it even if that effect doesn't hold in earlier years. You'll want to do something like forward chaining where you'll be able to model on past data, then look at forward-facing data. Fold 1, training, 1, test, 2. Fold 2, training, 1 2, test, 3. Fold 3, training, 1 2 3, test, 4. Fold 4, training, 1 2 3 4, test, 5. Fold 5, training, 1 2 3 4 5, test, 6. Q12, how is a decision tree pruned? Answer, pruning is what happens in decision trees when branches that have weak predictive power are removed in order to reduce the complexity of the model and increase the predictive accuracy of a decision tree model. Pruning can happen bottom-up and top-down, with approaches such as reduced error pruning and cost complexity pruning. Reduced error pruning is perhaps the simplest version, replace each node. If it doesn't decrease predictive accuracy, keep it pruned. While simple, this heuristic actually comes pretty close to an approach that would optimize for maximum accuracy. Q13, which is more important to you, model accuracy or model performance? Answer, such machine learning interview questions tests your grasp of the nuances of machine learning model performance. Machine learning interview questions often look towards the details. There are models with higher accuracy that can perform worse in predictive power. How does that make sense? Well, it has everything to do with how model accuracy is only a subset of model performance, and at that, a sometimes misleading one. For example, if you wanted to detect fraud in a massive dataset with a sample of millions, a more accurate model would most likely predict no fraud at all if only a vast minority of cases were fraud. However, this would be useless for a predictive model, a model designed to find fraud that asserted there was no fraud at all. Questions like this help you demonstrate that you understand model accuracy isn't the be-all and end-all of model performance. Q14, what's the F1 score? How would you use it? Answer, the F1 score is a measure of a model's performance. It is a weighted average of the precision and recall of a model, with results tending to 1 being the best, and those tending to 0 being the worst. You would use it in classification tests where true negatives don't matter much. Q15, how would you handle an imbalanced dataset? Answer, an imbalanced dataset is when you have, for example, a classification test and 90% of the data is in one class. That leads to problems. An accuracy of 90% can be skewed if you have no predictive power on the other category of data. Here are a few tactics to get over the hump. Collect more data to even the imbalances in the dataset. Resample the dataset to correct for imbalances. Try a different algorithm altogether on your dataset. What's important here is that you have a keen sense for what damage an unbalanced dataset can cause, and how to balance that. Q16, when should you use classification over regression? Answer, classification produces discrete values and dataset to strict categories, while regression gives you continuous results that allow you to better distinguish differences between individual points. You would use classification over regression if you wanted your results to reflect the belongingness of data points in your dataset to certain explicit categories, X, if you wanted to know whether a name was male or female rather than just how correlated they were with male and female names. Q17, name an example where ensemble techniques might be useful. Answer, ensemble techniques use a combination of learning algorithms to optimize better predictive performance. They typically reduce overfitting in models and make the model more robust, unlikely to be influenced by small changes in the training data. You could list some examples of ensemble methods, bagging, boosting, the bucket of models method, and demonstrate how they could increase predictive power. Q18, how do you ensure you're not overfitting with a model? Answer, this is a simple restatement of a fundamental problem in machine learning, the possibility of overfitting training data and carrying the noise of that data through to the test set, thereby providing inaccurate generalizations. There are 3 main methods to avoid overfitting. Keep the model simpler, reduce variance by taking into account fewer variables and parameters, thereby removing some of the noise in the training data. Use cross-validation techniques such as k-folds cross-validation. Use regularization techniques such as lasso that penalize certain model parameters if they're likely to cause overfitting. Q19, what evaluation approaches would you work to gauge the effectiveness of a machine learning model? Answer: You would first split the dataset into training and test sets, or perhaps use cross-validation techniques to further segment the dataset into composite sets of training and test sets within the data. You should then implement a choice selection of performance metrics. Here is a fairly comprehensive list. You could use measures such as the F1 score, the accuracy, and the confusion matrix. What's important here is to demonstrate that you understand the nuances of how a model is measured and how to choose the right performance measures for the right situations. Q20. How would you evaluate a logistic regression model? Answer: a subsection of the question above. You have to demonstrate an understanding of what the typical goals of a logistic regression are, classification, prediction, etc., and bring up a few examples and use cases.